So after seeing all the different types of gear trains, we finally come to the epicyclic gear trains. This is the kind of the sum which is always asked in the exam. The exam question is always on an epicyclic gear train. This is the simplest kind of an epicyclic gear train that is possible. So basically, what is an epicyclic gear train? An epicyclic gear train is a gear train in which the axis of rotation of a gear is also not fixed. That is, the axis of rotation of a gear can also change. For example, in this case, assume that gear A is fixed. Then if gear B starts rotating, the gear B, imagine it is rotating in the anti-clockwise direction. It will start going like this about gear A, in which case the gear B itself will be revolving around gear A. It will be rotating also, it will be revolving also. It is like gear A will be your sun and gear B will be your earth or any other planet. So epicyclic gear train is also known as sun and planet gear train. Okay. So in this question we are given 3 gear trains and there is an arm. In almost 99% of the epicyclic gear trains that you will see, there will always be an arm. This arm is used to connect the sun and the planet gears to each other. Okay, so in this question there are 3 gears A, B and C, and these gears teeth have been given. Gear A has 48, gear B has 24 and gear C has 50 teeth. There is this arm and the arm is rotating at 400 rpm in the clockwise direction. So with this they are asking us to find the speed of gear C, that is wheel C, when gear A is fixed, and in second case they are asking us to find the speed of gear A when gear C is fixed.
So this will be the first sum on epicyclic gear train. As you can see, we have drawn the diagram and written the given data and what is to be found. The next step whenever you are solving an epicyclic gear train is to draw this table. I have explained the table to you in the previous video, but again I will explain it to you once again. See, the table basically consists first of the steps. The steps are always fixed. These steps are never going to change. Okay, the first step is to fix the arm. Every epicyclic gear train will have at least one arm. What you have to do is you have to fix the arm. When you fix the arm, what does that mean? It means that its RPM is 0. Okay, then after that you have to give +1 rotation to any gear you like. Okay, so in this case I have given +1 rotation to gear A, but it is not necessary to give it to gear A only. You can give it to gear B or gear C. It doesn't matter. The final answer will always be same, whichever gear you give the +1 rotation to. Then we will fill up this entire thing. Okay, in this table you have to write all the kinematic links that are present in this mechanism. Okay, all the separate acting gears and arms that are present in this. For example, in this diagram you can see 3 gears, gear A, gear B and gear C, and you can see an arm. This is your arm. Okay, in your table the first thing should always be your arm. So I have written the arm first and then I have written the 3 gears, gear A, gear B and gear C. So what is the first step that we have to do? We have to fix the arm. In this table you have to write the RPM of each and every element, right? So if you have fixed the arm, the RPM of the arm will be 0. So we can write 0 over here. Now what will be the RPM of gear A? We have told we have to give +1 rotation to gear A. So this will be what? +1. Now we have to find out what will be the RPM of gear B. We can look at the diagram. See, in this diagram gear A and gear B are directly meshing with each other. They are meshing with each other over here. So we know from our basic formula. What do we know from our basic formula? RPM of gear B upon RPM of gear A is equal to teeth of gear A upon teeth of gear B. Using this formula we can write what will be the RPM of gear B. So RPM of gear B will be teeth of A upon teeth of B into RPM of A, and our RPM of A is +1. So this will be 1. This will get reduced to TA upon TB. But there is a difference. In this table the direction is also important. Okay, so +1, whenever you have a positive sign means anti-clockwise rotation. In physics always anti-clockwise rotation is termed as positive. So if A is rotating in the anti-clockwise direction, B will rotate in the clockwise direction because they are externally meshed. So B's rotation will be in clockwise direction, which is negative. So the value of gear B's rotation will be minus TA upon TB. Right? We have completed this. Next we have to find out what will be the RPM of gear C. So to find out the RPM of gear C, we have to see which gear is gear C meshing with. Gear C is meshing with gear B. So we can use this same logic to find this. The RPM of C upon RPM of B is equal to number of teeth on B divided by number of teeth on C. So now RPM of C will be TB upon TC into NB. Okay. Now what TB upon TC is same. What is the value of NB? NB is minus TA upon TB. Okay. It is minus TA upon TB. So TB are going to cancel. We are left with minus TA upon TC. But you have to remember, again this is external meshing. So even though it is currently minus TA upon TC, because of external meshing we will have to put on another minus sign. So it will be minus of minus TA upon TC. Okay, I will repeat this point just so you understand. See, over here we wrote only TA upon TB and then we put the minus sign because it was externally meshing. Same, we wrote whatever was present over here. What was present over here? Minus TA by TC. Then we check the meshing whether it was internal or external. Because it is external, we put another minus sign. So basically this will turn into plus sign. Okay, we will look at it in the next step. What is the second step? The second step is to multiply all the RPMs of the first step by a constant m. It is not necessary to use the constant m only. You can use any constant, small a, small b, small x, small y, but make sure that the alphabet is small because capital alphabets are used for the gears. Okay, we will continue with m. So 0 multiplied by m is 0, plus 1 multiplied by m is m, minus TA by TB multiplied by m will be minus m TA by TB. Similarly, this minus minus is plus, so we'll get m TA by TC. Okay, what is the next step? Add n to all these rotations. Okay, these RPMs are currently our RPMs. We have to add n to all. So plus n plus n plus n plus n. And what is the last step? We have to do total of all the elements. That is, we have to add these up. So 0 plus n is n. M plus n is m plus n. Minus m TA by TB plus n can be written like this. In a similar way, this can be written as n plus m times TA by TC. Okay, so we have completed our table. Whenever you get a question on epicyclic gear train, always remember that you have to draw this table and you have to fill it up. Okay, so now we will see what are the given conditions to us. What are the given conditions in this question? So TA is given as 48, TB as 24, TC as 50. We can substitute those values over here. Additionally, they have given us the RPM of arm, which is 400, but in the clockwise direction. As I just told you, in physics, anti-clockwise is positive and clockwise is negative. So this is negative 400. Okay. According to our table, what is the RPM of your arm? N. So from this, if we can say that, I will write it over here. We can say that N is equal to minus 400. Why? Because from our table, the RPM of arm is N. And what has been given to us? It has been given to us that RPM of arm is 400 in clockwise direction, which means minus 400. So that I have written here. Okay, so N is equal to minus 400. What are they asking us to find? They are asking us to find the RPM of C when A is fixed. That is when RPM of A is 0. So we have to find RPM of C when RPM of A is equal to 0. When RPM of A is equal to 0 means what? M plus N is equal to 0. So we can write m plus n is equal to 0. This will become our equation 2. This is our equation 1. N is equal to minus 400. Right? Solving these two equations simultaneously will give us m is equal to 400. Right? So we found the value of m, we found the value of n. Now substituting these values, what do we have to find? RPM of C. What is the equation of RPM of C? N plus m into TA by Tc. So we will substitute the value of n and m in this equation. N is how much? Minus 400 plus m is how much? 400 into TA. What is TA? 48. And what is Tc? Tc is 50. So this is equal to minus 400 plus 400 into 48 divided by 50, which comes out to be 384, which will give us minus 16 RPM. So as I just told you, clockwise is negative. So RPM of C is 16 RPM in clockwise direction. Okay. This was the first part of our sum. In the second part of our sum, what are they asking us? They are asking us what will be the RPM of A when C is fixed. Okay, what will be the RPM of A when C is fixed? So how to solve this part? Again, N will be equal to minus 400 only, because N of arm is 400 clockwise. That is not changing. That is remaining the same. What is changing? N of C now becomes 0. So this equation will be equated to 0. So we will put N plus m into TA by Tc is equal to 0. Nc is equal to 0. Okay. So N is what? Minus 400. TA is what? 48. Tc is what? 50. Substituting all these values in this equation, minus 400 plus m into TA by Tc. See, you will get two different values of m. This is for part 1. The part 1 finished over, part 1 got finished over here. Okay, we are solving this for another different case. In the first case, Na was fixed. In second case, Nc is fixed. Okay, so please pay attention to this. M into what is TA? 48. What is Tc? 50. Okay, is equal to 0. Taking minus 400 to that side, m into 48 by 50 is equal to 400, implies m is equal to 400 into 50 divided by 48. This will go up, this will go down. So m will be equal to m is equal to 416.67. Right, we got the value of n is minus 400, m is 416.67. What do we have to find? We have to find the RPM of A. What is the equation of RPM of A? M plus n. So Na is equal to m plus n. The value of m is positive 416.67 and value of n is minus 400. So it gives us 16.67 and this is positive. As it is positive, it means clockwise rotate, anti-clockwise. Positive is anti-clockwise. So n of A is equal to 16.67 in anti-clockwise direction. So NC is 16 RPM clockwise direction. This is 16.67 RPM in anti-clockwise direction.